A better way of generating either low pass, high pass, or band pass filters is using a Gaussian signal. So let's just quickly write that. Now normally the area under the Gaussian signal, the total area of that is 1. But in our case, the only thing we are interested in is the maximum amplitude of the Gaussian signal. So for us, we have to multiply the output of the Gaussian with sigma divided by 0.4, and this will scale the Gaussian signal, so whatever value we have, the maximum value will always be 1. And then we can set the location of the Gaussian using mu and the width of the Gaussian using sigma. And then we can use the frequency range as the input for the Gaussian to calculate the filter. In case of the Gaussian filter, we will be using a bandpass filter instead of a low-pass filter like we had with the ideal filter. And applying the filter is the same. And since the filter is slightly more complex, then we can also plot the filter itself, so you can get a better understanding of how it applies to the frequency domain.